Welcome everyone, my name is Scott and welcome back to this tutorial series on building a space shooter game with Phaser 3. Previously we worked on loading in our game assets and we started to create our player class where we created our player game objects, so our ship, and we added in our animations to our scene. If you missed the previous video, there'll be links in the video description to the source code to this point, as well as the complete source code for this video. There'll also be links to the previous videos if you'd like to catch up. So let's get started. So now that we have our Phaser game objects, our container representing our player's ship in our game, the next thing we need to do is we need to start adding in our components that we previously discussed. And so the first one we're going to start working on is going to be our input components, so then that way we can move our ship around our scene. So in order to do this, we'll be using the Phaser 3 cursor keys game object. And what this is an object that's going to allow us to listen for keyboard events from our arrow keys, as well as the space key for our game. And so to see an example of this, what we're going to do is in our game scene, let's go ahead and make a new variable, do const. We're going to go ahead and do cursor keys, and we're going to set equal to our scene. So we'll do this, we'll do our input manager, we'll do our keyboard plugin, and then we'll go ahead and do create cursor keys. And so what this is going to do, this is going to create an object with the properties for each of our arrow keys as well as our space key. And now what we can do is we can go ahead and listen for this in our update event on our scene. And so let's go ahead and just store a reference to this. So we'll do this, our create cursor key, our cursor keys, and then we'll go ahead and add our update method. And now what we can do is in our update method, we can go ahead and check to see if any of our keys are actually being pressed. And so go ahead and see an example of this. What we'll do in our update method is let's go ahead and add a console log statement, and we'll go ahead and do this. We'll reference our cursor keys. And so this is going to be an object with our various keys. And so we can reference the up property to reference our up arrow key. And then these are going to be objects with different properties on them. And one of them is down. And so this is a Boolean value that will be set to true if we're holding the key. And it'll be set to false if it's not being pressed down currently. And so what I'm going to go ahead and do is I'm just going to copy this. I'm going to paste it a few times for each of our arrow keys, just so we can see an example. And so we'll have up, we'll have down. Let's do left. Let's go ahead and do right. So now we'll see in our console log, we're logging false because I'm not pressing any arrow keys. And so if I go ahead and press up on my keyboard, we'll see that's true. Down, we'll see the second one's true. Left, and then right, we'll see that we toggle each of those keys. And so this is just a nice shorthand method to go ahead and add listener events for each of these keys. And then we can go ahead and use this object to check their state. And so now that we know how the cursor keys object works, what we're going to go ahead and do is we're going to go ahead and build a component to go ahead and have all this logic be located inside. And so what we're going to go ahead and do is let's go into our source folder. We'll go ahead and we'll make a new folder. We'll go ahead and call this components. And so under here, we'll make another subfolder. We're going to call this input. All right, so the first one we're going to go ahead and do is we're going to go ahead and create a generic input component. And so this component's going to have an abstraction for these key presses here. So like up, down, left, and right. And then that way we can have different implementations of this input component. And one of them is going to be this keyboard input component where we'll use our cursor keys. And so this is going to allow us to reuse that logic for our enemies because our enemies don't need to react to our keyboard presses. They need to go ahead and handle input in their own way. And we'll get more into that once we build out our enemy classes. So for our generic component, let's go ahead and add a new file. We'll do input component.js. And so what we'll do is let's go ahead and export out a class. We'll export class. We're going to call this input component. And so on our component, we're going to need properties to track our arrow presses as well as our space key. And so what we're going to go ahead and do is we're going to go ahead and add these properties that we're going to have them be protected, which means they should only be referenced within this class or our child classes that extend this class. And so what we'll do is we're just going to go ahead and do up, we'll go down, let's do left, and we'll do right. And we're just going to go ahead and call this one shoot instead of space. And so what we're going to go ahead and do is let's add our constructor. And so our constructor is going to be responsible for setting all of our initial values for this. But what we're going to do is we're going to go ahead and put that in a method so that way it's reusable. And so what we're just going to do is we're just going to call this. We'll make this a public method, so let's go ahead and do reset. So now what we're going to go ahead and do is let's add that method. And for each of our properties, and so we'll do up, we're going to go ahead and set it equal to false. And we'll go ahead and do the same thing for each of these. And so what this method will be doing is in our constructors, go ahead and set our initial values, but then later on, we could call the reset method from another class to go ahead and reset these initial values. And we'll also be able to reuse this in our child classes that we'll create soon. So the last thing we're going to go ahead and do for our properties is we want to have a way to go ahead and return these values. And so because we do want this to be protected, we're going to go ahead and add getters to go ahead and return these values. And so to go ahead and add our getter, we'll do get, and we're just going to do left is down. And then what we'll do is we're just going to return this and then our left property. And so we'll do this for each of our fields. And so I'm just going to paste this a few times. And so we'll have right is down. We'll go ahead and have down is down, up is down, and then finally shoot is down. Then we just need to update our references. We'll have shoot, we'll have up, down, and then right. All right, so that gives us the basis for our generic component. And now what we can do is now we can create implementations of this component and tie that to our core logic. So what we're going to do now for our keyboard input that we did here, we're going to go ahead and create a new component that's going to go ahead and create this logic here, and then go ahead and set our values inside our component that we create. And so what we're going to go ahead and do is let's go ahead and make a new component. We're going to go ahead and do keyboard input component.js. We're going to do export class. We're going to do keyboard input component. And we're going to go ahead and have this extends our input component. So for our input, we just want to make sure we have .js. So then what we're going to go ahead and do on this component, we're going to go ahead and create our cursor keys. So just go ahead and copy this from our game scene, and we'll add that as our private property here. Let's go ahead and add our constructor. And so in order to create our cursor keys, we'll need our phaser scene. And so that'll be one of our only argument. And then what we'll do is we'll call our super method. So we'll go ahead and call our parent class. We don't need to pass anything. And now we can go ahead and create our cursor keys instance. And so that's going to be our scene, input, keyboard, and we'll do create cursor keys. So now what we can do is we can go ahead and add an update method that we'll go ahead and call from whichever scene that we add this component to, and then we'll go ahead and check for our cursor keys. So then what we'll go ahead and do is now we're going to go ahead and set our up, down, left, and right properties based on if our cursor keys are being pressed down. So what I'm going to do is I'm going to copy all this from our reset. We're going to go ahead and paste that inside our update. And then what we'll do is jump over to our game scene. I'm just going to go ahead and copy this where we check for our up key is down. We're going to paste that here. So then what we can do for each of these, we can just go ahead and paste and we'll update it to use the appropriate key. So we'll have down, we're going to have left. Let's go ahead and do right. And now we'll go ahead and do space for our space key. All right, so the one last thing we're going to go ahead and do before we test our component is we're going to go ahead and add a feature for allowing us to lock our input. So then that way we don't do anything when our component is locked. And so one example of this is after our ship is destroyed, we want to go ahead and have the animation play for the ship being destroyed and wait a second or two before we spawn our ship. And when that happens, we don't actually need to handle input on our game object because we want to reuse that same game object. And so we'll go ahead and prevent input from moving our game object around. Let's go ahead and do this. We're going to add a property to keep track of this. And so we're just going to do input locked. So what we'll do is first we'll go ahead and add a default value. So in our constructor, we're going to do input locked. We're going to go ahead and do false. Let's go ahead and add a setter. So we can go ahead and update this value. So we'll say lock input. And then for our argument, we'll expect a value. And then we'll go ahead and do this. Our input is locked. And we're going to set it equal to the value that's provided. Then in our update method, we're just going to go ahead and check to see if this is set to true. And so if we lock our input, we can go ahead and just return early. And then what we'll do is we'll go ahead and call our reset method on our parent class. So then that way we can go ahead and reset everything back to false so we don't handle any input. All right, so real quick before we test our code, what we're going to do is we're going to jump over to our component diagram. And so what we did is the first thing we did is we created our input component. And our goal for this component was we want this just to be a generic class that is going to be extended in other classes that's going to have the core functionality we need for input. And so for our game, this is really the up, down, left, and right keys. So we can tell if a player is moving around in our game or an enemy, and we want to know if they're actually trying to shoot their weapon. And so that is the point of this class here. Is we just have that abstraction. So then that way, whatever type of implementation is built using this as the base class, it'll have its own functionality for figuring that out. And then so next what we did is we created our keyboard input component. And because we extend that input component, we now have these properties here to go ahead and set. And now we can have our own implementation of how we figure that out. And so we decided to go ahead and use our Phaser 3 cursor keys to go ahead and handle input in our Phaser game. And so by using that, we can go ahead and set those values based on our keyboard events. And then what we'll be able to do later on is once we work on our enemies, we can go ahead and create new components for those that'll have its own AI logic for figuring out what input should be happening for that enemy. All right, so now we have our components. What I'm gonna go ahead and do is jump back to our game scene. I'm gonna go ahead and remove our update logic that we have here. Go ahead and remove our cursor keys, and let's go ahead and remove our property. And then we'll go ahead and jump over to our player class, and this is where we'll go ahead and create our component instance, and we'll add it to our game object. And so the first thing we're going to go ahead and do is let's go ahead and add that as a property in our class, keep track of our components. We'll do keyboard input component. And then what we'll do is after we create our Phaser game objects, let's go ahead and create our components. We'll do this. Our keyboard input component is going to be equal to a new instance of our keyboard input component. And so for this, we need our Phaser scene. So we'll go ahead and do this.scene to grab the scene from our Phaser game object. All right, so the next thing we need to do is now we need to go ahead and add the ability to go ahead and call our update method in our component. And so what we're going to go ahead and do is let's go ahead and add an update method to our player class. And for our update method, we're going to go ahead and expect our timestamp and our delta time from our Phaser update game loop. And what we need to do now is we need to invoke this method. And so one way we could do this is in our game scene, we could add back in our update method and then manually call our player.update method here and run that logic. But as our game gets more complex and we add in more game objects, this becomes very tedious if we need to do this for each of our game objects. Another approach, what we could do is we could go ahead and listen for our Phaser 3 scene events, and we can go ahead and listen for our scene update event. And when that happens, we can keep that logic inside this class here and have that invoke our update method. And so this will be really nice if we do this for each of our components, because then they're responsible for listening for when we need to run our update logic and for cleaning it up once our game object is destroyed. And so this is actually really easy to do because each of our Phaser 3 game objects has the event emitter built into it. So now we can go ahead and listen to events. And so this is going to be really easy to do because on our Phaser scene, we have an event emitter that we can listen for events for. And likewise, we also have this on our game object, so we can listen for when our game object is destroyed. And so to make this happen, what we can do is we can reference our scene that our game object has been added to. We can then reference our event emitter, and then we can use the on method to go ahead and register an event listener for a particular event. And the event we're looking for will be our phaser. We want our scenes, and then we want our events, and then the update event. And so then what this is going to allow us to do is now provide a function that we want to run every time this event fires. And I'm just going to go ahead and reference our update method here. And then we'll go ahead and pass in this for this context. So then that way we have the right context of when we're running this for our player instance. So because we're creating an event listener, we eventually need to clean this up from our game. And so to do this, we're going to go ahead and listen for when our Phaser 3 game object is destroyed. And to do that, we can go ahead and use our event emitter that's built into our game object. And we can use the once method, so we only fire this one. We only have this event listener fire one time. And the event we're looking for will be our phaser, our game objects, our events, and we want the destroy event. And so anytime the phaser scene is going to clean up our game objects, or if we manually destroy them, this event will be triggered for that game object. And now we can go ahead and have logic run that's tied to this. And so what we're going to go ahead and do is we'll go ahead and add in our own function. We need to go ahead and pass in this for our context. So we have the context of our player. And now what we want to go ahead and do is now we want to go ahead and turn off that event listener that we registered here. And so to do that, we'll copy that line of code. Instead of using the on method, we just go ahead and use off, and that's going to go ahead and turn that off. So now we'll stop reacting to that event. All right, so then what we should be able to do now is if we go ahead and do a console log inside our update, let's log our timestamp and our delta time. And so when our scene refreshes, we'll see right away we get a bunch of logs starting to jump into our console. So what's happening here is in our game scene, every time our update lifecycle event fires, so each tick of our game loop, we're going to go ahead and invoke our update method inside our player class here. And that's because we register this event listener for that scene event. And so now what we can do inside our update method is now we can go ahead and reference our keyboard input component, and we can go ahead and call our update method to go ahead and run that logic. And so now what we should be able to do is if I go ahead and do console log, if we reference our keyboard input component after we do our update, let's go ahead and check to see if one of our keys is being pressed. And so what we'll do is we're going to do down is down. As we'll start seeing this, let's remove this console log for our timestamp. And so we'll see now if we go ahead and press our down key, we should see that true is being logged. We can see our logic is actually working how we expect. All right, so now we've seen that our input is working how we expect. The next thing we're going to go ahead and do is now we're going to start adding in our components to actually do something with that input. And so what we're going to do is we're going to focus on our movement components, and we're going to focus on our horizontal component for our player. So one thing that's going to be different between our input and our movement components is we're not going to have a base class that these components will extend. Instead, these will be their individual components that have their own logic. And so to go ahead and do this, let's go ahead and jump over to our code. Let's go ahead and make a new subfolder under components. I'm just going to call this movement. And let's go ahead and add a new file. We'll go ahead and call this horizontal movement component. .js. And so let's go ahead and export our class. We'll export class, and we'll have horizontal movement component. And so now for our horizontal movement component, what we are going to want to do is we're going to need a reference to our input component. So then that way we can check to see if our left or right keys are being pressed. And if they are, then we're going to go ahead and move our phaser 3 game object around in our scene. And so in order to do this, we're going to need to know about our input component, and we'll need to know about our phaser game object that we want to go ahead and move around. So what we'll do is we'll add two properties to keep track of this. So the first one is going to go ahead and do game object to keep it generic. So that way we can reuse it with containers and sprites and different things like that. And our second one is going to be our input component. And so for our input component, we'll also keep this generic because we don't care if it's a keyboard input component or one of our bot ones. We just want the base input component. So then that way we can check for our properties and then move our game object accordingly. So now what we can do is let's add our constructor, and then we'll go ahead and add our arguments. So we're going to need a game object, and we'll also need our input component. So then what we'll do is let's go ahead and set those properties. So we'll leave this game object will be equal to the game object. This input component will be equal to our input component. All right, so what we need to do in our component is we're going to go ahead and rely on our phaser physics to actually go ahead and move our physics game object around our scene. And so to do that, we're going to go ahead and have to update some of the properties on our physics body that will allow us to go ahead and move our game object. And so to go ahead and do this, let's go ahead and add in our update method. And what we'll want to do is we're going to want to check to see if our input is being pressed, and if so, we're going to go ahead and update our game object's velocity to go ahead and start moving in one of our directions. And so what we'll go ahead and do is we'll use if, we'll do our input component, and we'll go ahead and check if left is down. And so if left is down, we want to go ahead and update our game object's X property to be negative. So we start moving it this way across our screen. If it's the right keys pressed, then we want to go ahead and increment it so we start moving this way. And so to go ahead and do that, we're going to go ahead and reference our game object. We're going to go ahead and grab our physics body from it. And then we're going to go ahead and set our velocity. And so for our velocity, there's a few different ways we can set this, but what we'll want to do is we're going to want to reference our X property. And now we want to go ahead and modify that value, and we're going to decrement it by some type of value. And so for this, we're going to go ahead and let's just go ahead and we'll hard code 20 for the time being. Is just go ahead and start modifying this. Otherwise, what we want to do is we want to check to see if our right key is pressed. So we're just going to go ahead and copy this. Let's go ahead and paste it. And we're just going to do right is down. And if the right key is pressed, then we want to go ahead and increment this. We can bump up that velocity. So we'll go ahead and increment it by 20. Finally, what we want to do is if neither of these are pressed for our horizontal component, we want to go ahead and reset this back to 0. And so go ahead and reset that. What we can do is we can reference our physics game object, our body, and then we're going to go ahead and call set angular acceleration. We're going to set to 0. And so that's going to go ahead and reset all of our acceleration that's being calculated based on this velocity here. And so what we're going to do is let's jump back to our player component. Let's go ahead and create an instance of our components. We can do some testing. So what we'll do is let's add a new property. So after our keyboard input component, let's go ahead and add in our horizontal movement component. Then what we'll do is let's go ahead and create an instance. So after our keyboard input, we'll do this. We'll do a horizontal movement component will be equal to a new horizontal movement component. We'll go ahead and pass in this for our game object. And then we want to go ahead and pass in our keyboard input component. All right, so before we can actually test, there's a few things we need to do. One of them is in our update method. We need to go ahead and call our update on our component. And then what we need to do is now we need to go ahead and actually enable our game object, our container, to be enabled for physics. So typically for your physics game objects, what we would want to do, like if it was a sprite, we would use our physics plugin on our scene, and then we'd reference what type of game object we want to add. And so we use the add, and then like if I want to go ahead and create a sprite, I would do this. And what this is going to do under the hood is Phaser's automatically going to go ahead and create a physics body for that game object. And by default, our containers do not have this. And we need to manually create one and attach it to our game object if we want to go ahead and use physics on our container. And so to go ahead and do this, right after we add our game object to our scene, we just need to go ahead and do this. We reference our scene. We'll go ahead and reference our physics plugin. Now we want to go ahead and use the add method. We want to do add existing. We want to pass in our game object. So now what's going to happen is our scene is going to refresh and we're going to see our ship appearing. And we're also going to see this purple bounding box. And so what this purple box is, this is the body representing our container. And so when we initially set up our game configuration, one of the things we did was we went ahead and set debug to true, and that's why this box is being rendered out. If we set this back to false, we'll see we no longer see our physics body and we can't use it for debugging. And so we're just going to go ahead and leave that for true for the time being, but that's what that is. And so now that we can see our physics body, now we need to go ahead and modify it so that way it's actually in the position over our ship and it's more scaled down to actually fit around our ship. And so to do this, we'll go ahead and reference the body now on our container. And the first thing we're going to do is we're going to call set size, and this is going to allow us to modify the overall size of it. And so we're going to go ahead and do 24 by 24. So now it's shrunk down, looks much better. But now we need to go ahead and modify its position. And so our body is being placed in the origin of our container here. We actually want to be taking up the whole container. We'll go ahead and do this. Let's reference our body again. We're going to do set offset. And now we're just going to go ahead and modify this to be half of our other values. We'll do -12. And now we can see our body's actually over our ship. All right, so go ahead and save. We should now be able to test our changes. So if we tap one of our keys, we'll see our ship starts moving in the direction we press. However, we'll see as we hold our key, our ship keeps speeding up, and eventually it's so fast it's really hard to control. And so we can see our logic's working, but we're going to want to put some constraints in place so that we can control how fast our ship can actually go. And we'll want to put some logic in place so our ship can't actually leave our scene. And so to go ahead and address this, what we'll do is in our player class, let's go ahead and reference update our body on our container. And we're going to go ahead and set collide world bounds. We'll go ahead and set that to true. And so what that's going to do now is our ship won't actually be able to leave our scene, and so we'll keep it constrained within our view here. One last thing we're going to go ahead and do is let's go ahead and set the depth for our game object, and we're going to go ahead and set the depth of 2. And so what this is going to do is anytime we render out one of our game objects, Phaser will typically place those game objects in the order that we add them to our scene, but we can control that rendering process by setting a depth on our game objects. And so an object with a higher depth will always be rendered on top of other game objects. And so this will be nice later when we start adding in things like projectiles or our enemies. We'll have our ship always appear on top of them. Or even once we add our background, it would also appear on top of that. All right, so back to our horizontal movement component. What we'll want to do is we're going to go ahead and add some type of cap on how fast our ship can actually go. Because when we press and hold our left or right key, all we're doing is we're just constantly updating our velocity and we're constantly updating it. And so there's no upper bounds for how fast we'll be able to go. And so go ahead and set this bounds. What we can do is we can use the set max velocity property on our game object's body to go ahead and control that. So what we'll go ahead and do is in our constructor, we're going to have reference our game object's body. And so we'll go ahead and do game object, reference body. Let's do set max velocity. And so for our max velocity, let's go ahead and set this to 200. So when our scene refreshes, we'll see now when we hold our key, our ship does speed up, but eventually reaches our max threshold, and we're no longer able to go faster than that value. So this is much better control over our ship. However, when we let go of our key, our ship just keeps flying in the other direction. And so what we'll want to do is we're going to want to add some drag to our game object. And what that's going to do is once we stop providing input, our ship will eventually start slowing down and start deaccelerating. And so this would be simulate that there's another force pushing against it, and so that we start slowing it down. And so this is just going to give us a little more finer control over our ship as we're playing our game. And so to go ahead and do that, what we're going to go ahead and do is we'll do this. We'll reference our game object. Let's grab our body. First thing we're going to do is we're going to set damping to be true. And then we're going to go ahead and do this, our game object, our body, and we'll do set drag. And we'll go ahead and set this equal to 0.01. So we'll come back to these in 1 second. So now if we test our scene, we'll see as soon as we let go of our key, our ship starts moving, it starts decelerating really fast. And so this gives us a really nice control over our ship as we're playing our game. All right, so what we did here is the first thing we did is we set damping to be true on our physics body. And what set damping does is it allows us to control how drag is applied to our physics body. And basically what the drag is, this is going to control how our physics body will start to accelerate once there's no longer any movement detected on our game object. And so our object will start slowing down as there's no force being applied to it. And so the drag controls that deceleration. And what damping does, it controls how that's being applied. And so when it's set to true, we're going to go ahead and use a damping effect rather than a linear approach. And so by default, it's set to false. And so we'll literally apply the same amount repeatedly until our game object stops moving. And by setting it equal to false, what we can then do is we can control how fast our ship will start stopping. And so it's going to be between a value between 0 and 1. And so the closer this value is to 0, the faster ship's going to go ahead and stop. And so what this means is like when we use a value of 0.01, the body will keep only 1% of its velocity per second, and it'll start decelerating really quickly. And so the higher this value gets, we'll go ahead and it's going to go ahead and keep up its velocity and only lose part of it. And so just an example, like if I bump this up to 0.5, now what's going to happen is our ship's going to keep moving, and it takes a lot longer for it to eventually stop once there's no longer any input. Versus if I put this back to 0.1, now our body is only going to keep 1% of its initial velocity, is going to lose the rest of it until it eventually stops. And that's why we get this really nice quick break effect here. So as an example, if I comment this out, what will happen now if I set damping back to be false, we'll see now it takes a lot longer for us to eventually stop and our game object to actually slow down. All right, so the last thing we're going to go ahead and do for our component is we're also going to go ahead and add a reset method here. So we can go ahead and reset our velocity back to 0 if we need to. So we'll go ahead and do reset. What we'll do is let's go ahead and set our X velocity to 0. So let's copy this. We'll go ahead and paste that here. And we're just going to go ahead and change this to be set to 0. And then we'll also go ahead and reset our angular velocity back to 0. All right, so one last thing we're going to do is we're going to go ahead and move some more values to a configuration file, and we're also going to make some of them configurable for our component. And then that way, depending on which type of ship we're adding this component to, we can control our velocity and different things like that. So what we'll go ahead and do is let's make a new property. We're going to go ahead and call this velocity. And then what we'll do is on our constructor, let's go ahead and add this new argument. And we'll do velocity, and let's go ahead and do this. We'll do our velocity will equal to our velocity. So then what we'll do is down in our update method, instead of referencing our 20, we're just going to do this, and we'll reference velocity. So control that when we create our component. Then what we'll do is let's jump back to our player class, and when we create our component, let's go ahead and pass that value in. So we'll have our keyboard input component, and we'll go and pass in 20. Let's go ahead and save. And now what we'll do is under our source folder, let's go ahead and add a new file, and we're just going to call this config.js. All right, so now we'll do in our configs, we're going to create variables for each of those values. So we'll do export const. Let's go ahead and do player. We're going to go ahead and do movement, horizontal, velocity. We're going to set that equal to our 20. Then we'll do export const. Let's do component, and we'll do our movement, horizontal, and we'll do drag. We'll set that equal to 0.1. Let's go ahead and copy that, and we'll go ahead and paste it. And now we're just going to go ahead and do for our max velocity. And so we'll have our horizontal component. We'll do max velocity, and we'll set that equal to 200. So now what we can do is back in our horizontal movement component, we'll go ahead and import our config. That's come to the top of our class. Let's do import star as config from, and we'll do our config.js. And then what we'll do is let's go ahead and grab those values. So for our drag, we'll do our config, and we'll go ahead and grab our drag config, and we'll do our horizontal max velocity. Then we'll go ahead and do the same thing over in our player class. So what we'll do is let's go ahead and import our config for one level up. And so when we create our horizontal movement component, go ahead and do our config, and let's do our player movement velocity. So now if we go ahead and save, we should be able to test our changes, and we should see our ship is still moving how we expect it to. All right, so now we wrapped up our player's input and movement components. That actually brings an end to this video. In our next video, we're going to go ahead and start building our enemy game objects in our game. So as a reminder, there's a link in the description of the video as a complete source code for this video. And as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video in the series is released. For more great Phaser 3 content, please see the links on your screen now.